So that probably means that. That means that me and Luke is around me.
Oh, I just want to know how bad I did.
I definitely have better transportation.
Okay, start off. Wait, total, like, the ones we've taken on this
Yeah.
one.
Maybe I should have. I was like, pushing out because now everyone's waking up. My bad.
It's like the worst Thursday night football game of all time.
It was pretty ugly, yeah. But a dub is a dub is a dub, so.
Neither team, that should have been a tie game. That was.
What was the
What are we
score?
talking about?
10 to 7.
Are you talking about the Broncos?
It was pretty gross to watch.
13-3.
That's impressive.
Was it really? Oh, man, I hadn't heard that one yet.
My friends were watching the Broncos game, and
There was at one point where I think the Raiders had 7 drives in a row with no first down in a row.
The game was so bad I switched it to hockey.
Yeah, it was not pretty, but yeah, you gotta find a way to win those ugly ones too. If we win tonight, 10 to 7, I'll take it. So,
oh, I don't want to cry. Oh my gosh. Let me get emotional.
okay.
No, about
There are ways to solve a 3-variable, 3-system of equation by hand, but the good news is we're not gonna do it by hand. Okay, so I don't really feel like there's a whole lot of credence in showing you how to do it by hand, because I don't really think there's any like time down the road where you're gonna be like, oh, I really need to be able to do this by hand, right? So I'm gonna show you how to do this. And saying that, they don't really talk about matrices until the next section, but we're gonna talk about matrices a little early because we're gonna use matrices to solve this. So this would be another method. Yesterday, we talked about 3 ways to solve a system, but the only way that we're gonna solve a 3-variable equation is by matrices. And you've done this in Algebra 2, but might need a little bit of a refresher to do this, okay? So in your calculator, we're gonna put this in as a 3x4 matrix. Okay, and it's gonna look like this. You're gonna do all the coefficients. 1, 6, 3. I always put like an imaginary dotted line in here. That's where the equal sign would go. And then 2, 1, 2, 3. And then 3, -2, 1, 0.
How do you put that in?
Okay, that's what we're going to go through here. Okay, so first thing you're going to start with is you're going to find your matrix button. For a lot of you, it's above the x to the -1 button on the left-hand side. Some of you have just a matrix button itself. Kind of depends on the calculator that you have. So you got to go second matrix on a lot of them. Okay, and then you're going to go to edit. And you're going to put it into one of the matrices, and you're going to put it in as a 3x4. You have like A, B, C, D, E, F, G. It doesn't matter which one you put it into. So I'm just going to choose A, and then you're going to hit 3x4. And then you're going to type in the numbers. Okay, once you're finished typing it in, then you have to hit second and then quit to get out of that screen. And that takes you back to your home screen. Okay, then what we're going to do is we're going to evaluate this function. Okay, so we're going to go back to matrix. We're going to go over to math. And you're going to scroll down until you get to RREF. And you're going to hit enter. Okay. And then, once again, you're going to go back to matrix. And then you're going to enter the matrix you just put it into. So I put mine into A. So under names where it says A, B, C, D, E, F, you're going to enter, I'm just going to hit enter for A. And it's going to say R, R, E, F of A. And it puts matrix A into that. And you get something that looks like this. Okay, and it doesn't put these dotted lines in here, but you get 3 numbers over here, okay? Now, over here on the left-hand side, this is what we call reduced row echelon form. That's what the RREF stands for, okay? RREF stands for reduced row echelon form,
I'm so mad.
okay? You're gonna have a diagonal of 1s, and everything else is gonna be 0s, okay? So what this means is this is 1x equals -2, 1y equals -1, 1z equals 4, okay? And so that would be the numbers that we need here, okay? So my answer today, yesterday we said our answer was an ordered pair. Today it's an ordered triple because you have an x, a y, and a z.
It's somewhere in oh, ref. It still doesn't work. Is it R-E? Oh, I did it!
That's right.
I did it.
Because you were just typing it up.
Oh. I'm doing it by myself.
Yeah.
I cannot do it in my calculator.
Okay. Casio.
Yeah.
Because I think the other one is so much more.
10 is 4 and a third, negative 10 and 2/3. My planter's failing.
That was the most complicated.
You go here and you go here.
They launched long breeze. One of them fell.
If I just do regular old man.
Mine's only truck. So how Kristen does.
I probably had it, I probably did it right.
She just got a dart and bounced off my head. I put a 2 instead of a 1.
Why is it 2?
The 3 -2 1. I put a 2 because I got the same.
Oh. Sorry, guys. Oh, you'll have not Cassie. Tannen, you're a little too late. I asked Tannen how you knew how to break it through the first one. Oh. Tannen, it's a little too late. I'm now in listening school, and school in my car is fine.
Yeah, so Casio's, if you have a Casio, okay, you're going to put it into your matrix. Okay, you got to go to option, and then you're going to go to matrix, and then RREF. Okay, and then you're going to type in right above 2, so you're going to have to go shift 2, and it says matrix or MAT right above 2. And then you're going to do alpha button, and then whatever matrix you put it into. So if like you put it into A, you'd go alpha A. Okay, so it should say RREF of matrix A. If you put it in the TI calculator, it's going to have that little bracket around it like that. Okay. So it's a little bit different process based on a Casio versus a TI, but you should still get something that looks like that. Okay. Anybody need help putting that in? Everybody figured it out? Okay. The other couple things that we're going to do today, I'm going to show you what infinitely many solution looks like. I'm going to show you what a no solution looks like. And then we're going to do a story problem with this as well. Okay. The good thing is we can use our calculators for everything, but it's going to look a little different. Okay. So let's try this one. X plus 2y minus z equals 4. 4x minus 3y plus z equals 8. 5x minus y equals 12. Okay, so when I put this one in to my matrix, this would be a 1, this would be a -1. This is going to be a 0 down here. If it's missing a variable, it's always got to go x, y, z. But if it's missing a variable, we're going to put a 0 in its place. Always watch your signs here too. This is a minus in front of the z, so we're going to treat that as like a -1. So we're going to go 1, 2, -1, 4, 4, -3, 1, 8, 5, -1, 0, 12. Okay, we're going to go through the same process. We're going to put that in. You could go back into matrix A. You could go into matrix B. What matrix you put it into doesn't matter. Just make sure you remember which matrix it was. So you got to go to Edit. And then you're going to type that matrix in. Make sure you choose the RREF that has 2 R's on it, because there's one that has just 1 R, and that will give you a different answer. Okay, this one gives you some decimals. We don't really want those decimals. So as that's in your calculator, math frac it, so hit math and hit frac and change it to fractions. Okay, so when I do that, I get something that looks like this. The bottom row here is the key, okay? Remember that this right here is like where the equal sign would be. So we're saying 0 equals 0. Well, what did we say yesterday when we had 0 equals 0? In infinitely many solutions. So this is what infinitely many solutions is going to look like, okay? The first thing that we notice is that we don't have a diagonal of 1s here. If we don't have a diagonal of 1s, that means something's wrong. That's what your RREF should look like. You should have a diagonal of 1s over here, and it should have 0s in these 2 slots right here. Okay, that's what RREF should look like, and then you'll have the numbers on the right. So that would be an example of infinitely many solutions, because my whole bottom row is 0s. Okay, everybody able to get that one? Okay. Okay, here's another one. And here's what I would tell you on your problems today. You don't have to rewrite the equations. Just take the equation that you have and just put it into your calculator. I'm just writing the equations up here so we have something to put in. I don't expect you guys to rewrite these equations out. Okay, so once again, my matrix, all of these today are going to be 3x4s. Everything's a 3x4 today because we have 3 variables, 3 equations. And once again, we're going to go put it into our calculator, into our matrix. Whatever matrix you want to put it into is up to you. And once again, I would do the math frac because you get some decimals again on this one. Okay, my answer on this one looks like this. 1, 0, -1/5, 0, 0, 1, 7/5, 0, and then we have 0, 0, 0, 1. Okay, the bottom row here is not an entire row of zeros, okay? So what we're basically saying here is 0 equals, because remember there's an equal sign here. That's one reason why I like to put that dashed line in here, so you know where that equal sign is at. 0 equals 1, okay? And yesterday when we had a problem like that, when we said 0 equals 1, does 0 equal 1? Well, obviously not. So we would say this one is no solution. That's our symbol for no solution, or you could write no solution. I'm okay with either one of those. Okay, so they look pretty similar, but on infinitely many and no solution, you're not going to get the diagonal of ones right here. Okay, and that's why we know something's different. We also don't end up with zeros in these two spots, so that tells us something's jacked up. Okay, so majority of the time you will get 3 answers, X, Y, and Z. If not, it could be no solution, infinitely many solutions, because those 2 answers are still in play as a possibility. Probably not going to see those as much as getting a 3 variable equation or 3 variable answer. All right, the last one I'm going to do with you here is on page 427. If you have your book, you can look at it. If not, we'll just talk about it together. And it's number 18. Okay? And you're going to have some like this on your quiz and on your test. And this is the part that makes some of these a little bit harder than just punching it right into your calculator. You are going to be able to use your calculator, but the hard part here is that the equations are not provided to us. We got to come up with the equations on our own, and then we're going to use the equations to put that information into our calculator. Okay? So this one is talking about the number of meals purchased at a restaurant that an average person will eat. They're either going to eat it in the restaurant, they're going to eat it in the car, or they're going to take it home. Okay? So that would be your 3 options. I'm going to go to the restaurant and eat there. I'm going to get it and I'm going to eat it in my car on the way to go somewhere, or I'm going to get takeout and just take it home and eat it. Those are your 3 options. And so they're talking about the changes or the number of meals that we can do. And so those are my 3 variables. X is at the restaurant. Y is in the car. Z is the number of meals that were take home. Okay, and that would probably be some data that a restaurant would keep, so they kind of know, like, how many meals are people ordering and that kind of thing. Okay, and so it gives me some information. We got to take all that information, we got to put it into, we know that we're going to have three equations. Okay, if we have three variables, we're going to have three equations. You can use whatever letters you want. I'm just going to stick with X, Y, and Z. If you wanted to use like R, C, and T for that represented the three, I don't really care, okay? But typically, I'm just going to stick with X, Y, and Z because that's what we're doing on a lot of these. All right, so the first one says there were a total of 170 meals a year. Like the average person will eat 170 meals out in a year. Seems a lot, right? 365 days in a year, so that means about every other day we're eating a meal from a restaurant or fast food or something. So 170 meals eating out. Okay, the total number of meals eaten in a car or at home exceeds the number eaten in a restaurant by 14. Okay, so the number of meals eaten in a car or at home, okay, so that would be Y plus Z, equals and exceeds the number eaten in the restaurant by 14. So eaten in the restaurant by 14 would be X plus 14. X is how many are eaten in the restaurant, and it exceeds that by 14, which means more than. Okay, that's my second equation. The third equation, 20 more restaurant purchased meals will be eaten in a restaurant than at home. Twenty more meals will be eaten in the restaurant than at home. Okay. Make sure I read that right. 20 more restaurant purchased meals will be eaten in a restaurant than at home. Okay. So that's my three equations. Okay, now here's the issue, is when we do this, and we already had this set up like this on the last couple of problems that we did, we want X, Y, and Z to be in that order, and then the number that does not have a variable attached to it is over here by itself. Okay, the first equation is good to go. The second equation is not. So what would I do to get that one in that format? Minus X, okay? So I'm gonna leave the first equation the same. The second equation, I'm gonna subtract X. $14 is going to stay over there. And then on this one here, you could do a couple of different things. I could subtract Z. And I know some people would be like, well, 20 is on the left. But when I rewrite this, it would be X minus Z equals 20. Okay. If you wanted to, you could subtract X and then subtract 20. Okay. It really doesn't matter either way. The equation would look a little different. This would then be negative X plus Z equals negative 20, so then all your signs would be different, okay? But it would still work the same way, okay? So how you solve the equation could change a little bit, but it would still give you the same answer, okay? That's our equation, or three equations, I should say. Okay, so my matrix here is going to look like this. 1, 1, 1, 170. Negative 1, 1, 1, 14, and then 1, 0, negative 1, 20. Okay. Sometimes you can have decimals and fractions, but I would say on this one, we probably want nice whole numbers because you're not going to order half a meal from a restaurant, you're gonna order an entire meal, right? And so your answer here probably should be a whole number. Okay, and what I get here's our reduced row echelon form again. And then over here, we have a 78, we have a 34, and we have 58. So 78 is the number of restaurant meals eaten, 34 are in the car, and 58 are take home. And those three numbers should represent and satisfy those three equations, okay? And that's how you would kind of make sure that it does make sense with everything that we have. Okay? Questions on any of those? Okay? If you need help with the calculator, please ask. I'll be glad to help you, okay? Here's your assignment for today. Same page we were just on, page 427. Okay, and like I said, I don't expect you to rewrite the entire equation out. Just put it in your calculator and solve it. There's not going to be a whole lot of work to show today. Okay? But the only work that you would have to do is the one that's a story problem. But I think I gave you one story problem. 17 is the only story problem on here. So you should be good. I stayed away from number 11 because number 11 had fractions in it. And I stayed away from number 15 because 15 was 4 variables. And we're not going to do any with 4 variables in it. Just 3 variables.